In this example, we're going to take a look at, or these two examples, excuse me, the last two, we're going to take a look at ones that have to be algebraically manipulated first before using the tables. We saw this at the very, very beginning of this video series with respect to tables. We have integral of 3x square root e to the 2x minus 7, okay, or e to the 3x, excuse me. So when we integrate this, one way to think about this is to integrate this such that we have e to the x times e to the 2x, and then square root e to the 2x minus 7 dx. Now we can try to do a u substitution. Okay, so if u is equal to e to the x, so be careful here. Okay, certainly we could do e to the 2x, but that might give us what's on the outside. But then we'd have a square root of u plus 7. All right, and then that would require another u substitution to evaluate, or even by parts. So the correct substitution for this one will be u equals e to the x, and du is e to the x dx. All right, so that takes care of this. This is going to become u square, as is this. All right, so now we're going to get u square square root u square minus 7 du. Right? And now we're going to go to the table, and hopefully there's a u square minus a square. So we're going to go over here, and we're going to go to our table, and we're going to go down to a form of u square minus a square. All right, so we have a square minus u square, which is close. So we have u square minus a square. And check this out, number 40 is perfect. It gives us precisely what we want. Okay, even though it's a little bit ugly, we could still get to the right answer with this. Okay, so we're going to use entry number 40. U equals u, a equals square root of 7. And we're just going to go ahead and now throw it into that nasty formula, and then we're going to have to back substitute when we're done. Okay, so this is going to be equal to u over 8, and then we have 2u squared minus a squared. And in this case, a squared is going to be 7. I was about to write a squared. And then multiplied by square root of u squared minus a squared. That's u squared minus 7, right? Minus a to the 4th, all right? So that's going to be 49 for a to the 4th over 8. Natural log absolute u plus the square root of u squared minus a squared. And then we have a plus c for our constant of integration. And last thing we're going to do, we're just going to back substitute u for e, all right? And that's going to end up with e to the x. So remember, u is e to the x over 8, 2e to the 2x minus 7, square root of e to the 2x minus 7, minus 49 over 8, natural log e to the x plus e to the 2x minus 7 plus c. All right, now this is really ugly. All right, and so let's see if for some reason we were to plug this into Wolfram Alpha. All right, and remember the original integral didn't look too bad. All right, remember our original integral for this was going to be e to the 3x square root e to the 2x minus 7. So if I throw that into Wolfram Alpha, okay, let's see what happens. All right, so we're going to have our exp of 3x times square root of exp 2x minus 7, close the exp, and that should be it. All right, so let's see what we get, if it does it at all. All right, and so it gives us this representation. All right, so we have an arc sign in there. All right, but it doesn't give us the natural log anywhere for this. All right, so it looks like that it went through, it did some factoring. All right, it might have used some trigonometric substitutions back in here to be able to, but we do have the 1/8, so that might be at least some semblance. And we do have a 49 in there. So And again, unless I looked at the wrong substitution, which I don't believe I did, it looks like this is the right one. None of these have an arc sign in it except for this one, but it's clearly not this one. So it's just a manipulation that we would have to do algebraically to be able to get back to this. All right. Boy, looks like a pretty bad one. All right. One last example. All right. So we have this one. We have integral of 3 minus x squared divided by x squared plus pi. All right. Now, with this one, there's no u substitution that we can start with. Probably the best approach sometimes is to just split it up into two separate integrals. And so we can separate this into 3 integrals of dx over square root x squared plus pi minus the integral of x squared over the square root of x squared plus pi dx. And what we might have to do is we might have to use 2 different entries to be able to figure this out. Okay, so we're going to look for something with x squared plus a squared under the square root. So we go back up here to our table. And we remember that x squared plus a squared, we had the example earlier, or a squared plus x squared in this case, was up at the beginning. And if we look, entry 25 looks pretty close to what we need for the first one. All right, so if we look at this first one, we have dx x squared plus pi. So for this one, we're going to use entry number 25. U is going to be equal to x, and a is going to be the square root of pi. All right. Now, hopefully, there's something with x squared over x squared, or x squared over root x squared plus pi, and it looks like right here that we have it. All right. So with this one, we're going to have a is again pi or square root of pi, u is x. All right. So go over here. So this is going to be number, I think this was going to be number 26, I believe we said. Right. And with that, we're going to have u equals x. And we're going to say that a equals the square root of pi. Right. And so if we go through and plug these back in, all right, now we can't forget the 3 that was from the original number 25. And that's going to be the natural log of x instead of u plus the square root of a squared. So that's going to be pi plus x squared. Okay. So that one wasn't so bad. And then minus the quantity. All right. So we're going to use 26. So that's going to be u over a, or u over 2, excuse me. So that's u over 2 or x over 2, square root a squared plus x squared. So pi plus x squared. And then we have minus a squared. That's minus pi over 2. And in fact, I'm just going to write that on the next line. It's way too long for us to try to write by itself. So just continuation. So minus pi over 2 times the natural log of x plus the square root of pi plus x squared. And then we have a plus c after that. All right, now these two actually look pretty close to being the same. So if you really wanted to, you could probably factor something out and collect it. But this might be the best that we can do. And the whole point of this example was just to kind of break it up algebraically to illustrate that it is possible for us to maybe do some algebra and use the table twice to be able to evaluate. Right. So that's everything that we're going to do in this section. Hopefully this illustrates some solid examples as to how to use the tables to integrate, and then also some of the benefits and detriments of using the computer algebra system to check.